Algebra 1, what's poppin'? Brand new notes, just copped them. Welcome back. We are back in the saddle. We haven't done a video in a while, but we're going to get back to our regular scheduled programming. We are moving on to a new unit today. If you hated the last unit, you might like this one a little bit more. If you hate math, I don't know how much better it's going to get from here. But buckle in. No matter what, we're going to be okay as long as you kind of just get some definitions down, you kind of get the process down and see what's going on, and just learn the skill of working with these things called monomials today. We're going to talk about those. We got to talk about what a polynomial is first, and a couple things before we get started. If you want the notes sheet for today, it is available for printing in today's Schoology folder. But if you can't do that, you can write them in your notes. That's fine. And same thing goes for the homework assignment. If you want to just get started on it early, you can. Otherwise, this puppy's waiting for you tomorrow in class. Okay, so let's start off with some definitions. Not my favorite thing to start off with, but it's good to be on the same page, okay? So we're going to talk about this thing. It's called a polynomial, all right? A polynomial is an expression consisting of variables, coefficients, positive exponents. That's kind of the gist of it, really. And I underlined coefficient because it's been a while since we talked about that. A coefficient is just the number in front of a variable. So here's an example of a polynomial. This is an expression. There's no equation. There's no equal sign. It's just an expression consisting of variables. The x is the y, the z. The coefficients, hey, these red guys, the numbers out in front, and the positive exponents, all of these exponents are positive. If these guys aren't showing up, it's implied it's an exponent of 1 technically, okay? Poly just means many, and nomial means terms, hence many terms. So we're going to talk about polynomials later on, but I just wanted to establish what a polynomial is before we talk about the lesser of the bunch, which is monomials, mono. Let's talk about a monomial for a second. We're going to go to our note sheet to start filling that out. We'll come back to playing around with exponents in a little bit, okay? Well, with a monomial, I told you poly means many. What does mono mean? Mono means 1, and we're still talking about nomials, so monomial is just one term. One term in a polynomial. Okay, and we'll give some examples of that. You kind of saw a couple right here. Those would be these terms right here. Here's a monomial, 2x squared. We also have negative 3yx. We have 6z cubed. Those are all examples of monomials. In fact, I'll even give one more. Just 4, just a number. A number is considered a monomial. Maybe it doesn't consist of a variable and an exponent at first glance, but this is basically what it would be. Anything to the 0 power is actually 1, so 1 times 4 is 4. We just never write it as this. It's just 4 is usually what we write it as. Okay, so if you just see a number like that, it still technically is a monomial. It's part of the polynomial expression, okay? And so we're going to do two things today. We're going to talk about adding and subtracting these guys, which you've already done before. And then we're going to talk about multiplying, which we've seen a little bit of it. Not too much, though, okay? So adding and subtracting monomials. I'm just going to tell you right off the bat, it's combining like terms. That's it. It's combining like terms. That's really all we're going to do when it comes to adding and subtracting monomials. You just see if they have the same variable and exponents, you can add them or subtract them. If they don't, you cannot combine them, okay? That's what it comes down to. So let's look at a couple examples. One of the ones I want to start off with is number 4. Okay, so we have 38x squared y minus x squared y. So all we want to do is let's determine first, are they the same variables and exponents? They are. They're both x squared and y. So now we can actually combine by adding and subtracting the numbers in front. If there's no number showing up, it's implied it's a 1. So we just do 38 minus 1 we get 37. And then I'm going to tack on the x squared y. And that's it. That's all it comes down to with adding and subtracting. It's really not that bad. Really not that bad. Okay? Let's look at something a little bit more complicated. Just a little bit. Like number 5 real quick. 2ab plus 9ac. Well, do they have the same variables and exponents? They do not. It looks very close, but one has ab, one has ac. So the answer to this is just the same exact thing. We don't have to do anything to it. We can't combine it. Okay? And that's really it. If the variables exponents are the same, you can't combine them. All right, now let's see something where there's a lot more stuff going on. Let's look at like number 11 right here. We got this expression right here. Now, once again, we have some terms that have y in them, like 3y and 4y. That's great. We also have some terms that have z in them. We have 9z and minus 3z. So I'm going to combine the numbers out in front, the coefficients, the 3 and the 4, those are the coefficients. I'm going to combine those because they have the same variable and exponent. So 3 plus 4 is 7. I'll have 7y. And then 9z minus 3z. 9 minus 3 is 6z. So this is plus 6z. And that would be my answer. So watch your signs out in front because they do matter. They absolutely do matter. All right? Let's look at something like number 14 now. All right? Variables, all the same. They all have m's and n's, but it comes down to their exponents as well. So this one's 10m squared n. This one's 7mn squared. These guys are not like terms. I cannot do 10 plus 7. It's not going to work. But let's look at this minus 1m squared n. Oh, well that is a like term of the 10m squared n. So I can treat this as 10 minus 1. I get 9. This is 9m squared n. And then, of course, I got to add on my 7mn squared. That guy cannot be added to the 9, but that's okay. We can just write it like this. They are different terms, okay? Now, some of these word examples might trip you up the most, so let's go over those for a second. First of all, we have like sum and difference for this. Sum means you're going to add these together. So you do 16y squared plus the negative 5y squared. That's kind of how you can treat it. The difference of 10x squared y and 2x squared y, that is subtraction. So I'm just going to do 10x squared y minus 2x squared y is how I would set that up. But sometimes you might see it written a little bit differently. We're going to use subtraction as an example. So you see subtract 9a from negative 15a. The from implies that we're actually starting with negative 15a. And then I'm subtracting, I'm taking away my 9a. So that was kind of cool. It's like a 3D movie. Like, whoa, that'd be cool. Get your 3D glasses on next time, all right? So this is how you would set that guy up. From negative 15a, you subtract 9a. Let's try it with this one. From negative 9cd squared, subtract. So from negative 9cd squared, we're going to subtract our negative 2 cd squared. Okay. Now why am I writing this one in parentheses, this number 18? Well, because we're subtracting a negative number, so you can see it's a minus minus, which makes a plus. So you got to be really, really careful. Do exactly as it's telling you to do, and you won't run into any issues. You shouldn't, okay? All right, that's adding and subtracting monomials. It's not too bad. Let's talk about multiplying them, okay? Now, before we do that, I want to play a little game with you guys. Not really a game, but I want you to kind of see what's going on. I'm going to start with 2, and I'm just going to take it to certain powers. Okay, if you want to use your calculator to follow along, you absolutely can. Well, 2 to the third power, that's 2 times 2 times 2, that is 8. 2 to the fourth, it's going to be 2 times 2 times 2 times 2, that is 16. And now we have 2 to the seventh. All right, if I do 2 to the 7th, that's 2 times 2. Yeah, there's 7 2's being multiplied, okay? So that should actually end up being 128, okay? So now this is what we're going to do. We're going to do 2 to the 3rd power from number 1 times 2 to the 4th power from number 2. Let's see what we come up with. Well, we know 2 to the 3rd power is 8, and we know 2 to the 4th power is 16. Well, what's 8 times 16? Well, I got to use a calculator. I have no idea. To be totally frank with you. It's 128. All right. Whoa. Look at this. Question 5. Compare your answers to number 3 and number 4. They are the same. We got the same exact thing. Probably doesn't mean anything. Let's keep going. Let's do our 3's. 3 to the 2nd power. 3 times 3 is 9. 3 to the 3rd power. 3 times 3 times 3 is 27. So this guy, there's the voice crack. 3 to the 2nd times 3 cubed, that's 27, or 9 times 27. That's 9 times 27. 9 times 27, that's 243. Okay. But I keep going back to number 3 and 4. They ended up being the same thing. And we know that 128 is equal to 2 to the 7th. So hold on just 1 second. 2 to the cube, 2 to the 3rd power, times 2 to the 4th, technically equal 2 to the 7th. What did we do with our exponents? It looks like we added them. 3 plus 4 is 7. Yeah, that's what it looks like. Well, all right. Using that same logic, if I added 2 and 3, that'd be 3 to the 5th. Does this equal 3 to the 5th? Is that what 243 is? Let's try it. 3 to the 5th power is 243. Look at that. So it turns out when we're multiplying numbers and they have the same base, which we're going to define in a little bit, when they have the same base, you can actually, when you multiply those numbers, you can add their exponents together. And we've kind of been doing that maybe when we're learning multiplication. You do 2 times 2, right? That's 2 to the 1st power times 2 to the 1st power. We know 2 times 2 is 4, which is also the same as 2 to the 2nd power. Okay? Interesting. So we're just adding them up. So that means if I have something like this where I don't know the number, but I have the same base, x, I just do 2 plus 5, and I get x to the 7th power. And that is actually what multiplying monomials comes down to. There's a little bit more to it than that, because sometimes you might get something like this, which we're going to talk about in a little bit what to get. This guy would just be 12x to the 7th. All right, so maybe you kind of have an idea what we're going to do with the coefficients. Let's define some stuff first. Okay, so let's go back to our definitions. And let's talk about multiplying monomials for a second. Go ahead and write this down. Pause the video if you need to. But when multiplying, we add the exponents of like bases. Okay, kind of like terms, but like bases. A base, it's the number or variable beneath the exponent. So for example, the x would be the base of this term, 3 would be the base of this term, and then obviously we have our exponents right there, okay? So I made a little diagram on your next part of this, and that's like multiplying the monomials. So if I have something like a monomial like this, 4x squared, the 4 is the number in front of my term, so it's my coefficient. My exponent is 2, it's to the 2nd power, and my base is the thing beneath my exponent, the x in this case, okay? So when multiplying monomials, let's formalize this, okay? The first thing you're going to do is you're going to multiply the coefficients. Okay? You'll multiply the numbers out in front first. And in that last example I kind of showed you when I was playing around with this stuff, I said 3 times 4 was 12. It is. I multiplied the coefficients first. Then I noticed these are the same bases, so I added their exponents together. Use the product rule, which we're going to define, to simplify the exponents. Okay, we're going to write the product rule right here. This is, if I have x to the m power, let's say, and I'm multiplying that to something with the same base, like x to the n power, we saw with our exponents, we just do x to the m plus n. That's all that means, where x is your base. Okay? So when I say look at that base right there, you kind of like the base in that problem, like we're going to look at number 3 in a second. Like the base of 4x squared is x right here. Okay? This base is also x, all right? And we're going to look at number 3. We're going to try it. So let's try these 2 steps to multiplying these guys. We multiply the coefficients. Okay, I got 4 and 3. 4 times 3 is 12. And then I use this product rule, okay, to simplify the exponents. So I notice my bases are both x. They're multiplying. So I'm just going to do x to the 2 plus 5 power, which is 7. And there we go. That guy is complete. Okay. Now multiplication rules still apply when multiplying the coefficients. So, you know, a negative times a negative is still a positive and that sort of stuff. So keep that in mind, okay? Let's try it with number 8. All right, number 8. Yeah, if we tried to, if we look, first of all, the bases are all the same. We all have y. That's great. Okay, so that means we can actually add all those exponents up. All right. The first thing we got to do first, though, is we got to multiply the coefficients. So that's 2 times negative 5 times 3. 2 times negative 5 is negative 10. Times 3 is negative 30. Okay. The bases are the same. So this is, again, if there's no exponent, it's implied it's to the first power. So this is just going to be 1 plus 2 plus 3, which is 6. There we go. Negative 30 y to the 6. Okay. Now, this is a skill. I don't want you to be so concerned with, oh, when am I going to use this in my life? When am I going to do this? Just, we're building skills right now. We're building blocks right now, okay? This isn't anything that is like, it's kind of like in basketball, you shoot free throws, okay? You're shooting free throws to practice. You're going to practice in the same spot. You're working on this one skill to get you better, so when game time happens, you're ready to go. What is game time going to be? It could either be the test, or it could be other stuff outside. Again, if we have time to talk about careers with this stuff, I'd love to, but let's focus on the skills right now, because that is what we are lacking, okay? Let's look at number 10 now. Again, now we have m and we have n's, right? Okay, now we have multiple bases. That's fine. That's fine. We just cannot add the m's exponents and the n's exponents. We can't do that, but we can add the m's, and then we can add the n's and put them next to each other, just like chilling. That's what they're doing right now. First, let's multiply those coefficients. We have 6 times 7 times 1, so that is 42. Okay. Well, let's look at my m's right now. So we have 1 plus 2, because we're multiplying the m's, so this is m to the 3rd power. And then I look at my n's. This is n, this is to the 1st power, this is n to the 4th power, so n to the 1 plus 4 power, so n to the 5th power. And that's my answer. Okay, let's look at 14. Uh-oh, coefficient alert. We have a fraction alert, okay? No biggie. When you multiply your fractions, you want to multiply top to top, bottom to bottom. Now, if we look at this 12, we can write that as a fraction like that, just 12 over 1, okay? And so let's multiply those coefficients first. 12 times 2 is 24. 1 times 3 is 3. And 24 divided by 3 is 8. So I'm just going to turn that into an 8, simplified, okay? Well, now we need to look at our bases. Well, I notice we have a y right here, and that's to the 1st power. We have a y right here, that's to the 4th power. So we're going to have y to the 1 plus 4, which is y to the 5th. And then we just have this x that's just chilling. Just plop it down next to it, man. It's all good, okay? We don't have to multiply the x by anything. We're just going to plop it next to it, okay? Technically, the x is multiplying the y, but in terms of adding the exponents, there's nothing to add. There's no other x base in there, okay? Finally, let's conclude with number 17. Okay, we have, now we have some adding right here, okay? So, first we're going to kind of do this like PEMDAS. We're going to multiply first, both of these, okay? We're going to be using our power rule. So, Let's look at this first side, okay? Well, 4 times 5, that's 20. Let's get that done right off the bat. Well, we also have a to the third power here, a to the first power. Okay, so a to the third times a to the 1. Well, that's 3 plus 1 power. So a is to the fourth power. B to the fourth, b to the second. 4 plus 2 is 6, so it's b to the sixth. There we go. Now let's go ahead, let's put our plus sign right there and see what else we can do. All right, multiply the coefficients. Well, we have a 1 times a negative 2, so that's going to be negative 2. Okay. A to the second, that's a to the fourth, if you add them. B to the fifth, b to the 1, that's b to the sixth. And if you notice now, kind of like when we were talking about adding and subtracting monomials, we have a monomial here, a monomial here. They also have the same variables and exponents, right? A to the fourth, b to the sixth. So I can combine these. Well, this is basically 20 plus negative 2, which is the same thing as 20 minus 2. So that is 18. And then I'm just going to copy down my variables and exponents. And that's my answer. Okay, so that was a combination of the power rule, right, what we did mainly on this page, and then it was also talking about the stuff we did here kind of more towards the beginning. Okay, so they're going to kind of work together, but for your homework, I want us to get some practice on multiplying monomials and adding and subtracting them, and then we'll go from there. All right, this is Mr. Knight signing off. See you later.